Hi everyone! In this video, you'll see some labs and demos that we've done in class related to Newton's first law of motion. Newton's first law of motion states that a body at rest tends to stay at rest, and a body in motion tends to stay in motion unless acted on by an outside force. This is also called the law of inertia. This first video that I'm going to show you is going to demonstrate Newton's first law and specifically the property of inertia. Inertia is any object's resistance to a change in motion. Here in this setup you can see that I have a graduated cylinder that's full of water. I also have a piece of cardboard, a toilet paper holder, and then on top of the toilet paper holder is finally where we have the egg. What I'm going to do is I'm going to hit the cardboard only. I'm not going to touch the egg, I'm just touching the cardboard here. So let's go ahead and see what happens. Alright, so I'm going to slow that down and move it back for us. Okay. And again, what I do is I hit the cardboard, and because I've applied this force to the cardboard, it moves over to the right. The egg, on the other hand, stays in the same spot for the most part. It does rotate a little bit because of its contact with the toilet paper holder, but in general, it just moves straight down due to gravity. So when we watch it back, you can see it all take place. And that's Newton's first law. A body at rest tends to stay at rest. You could try this at home using a glass of water instead of the graduated cylinder, but I do want to warn you, while I was practicing I broke 3 eggs, so you might have to be prepared to clean up a mess. This video will again demonstrate the property of inertia, or an object's resistance to change in motion. Here we have a graduated cylinder. You can use a cup if you're trying this at home. We have a piece of cardstock, and then finally a nickel at the top. And you already know what's going to happen to the nickel based on that first video, but let's watch it happen. Alright, so as I slow that down and back it up, you can see that as the cardstock is being hit, or the force is being applied to the cardstock, it's going to fly off to the right, and then the nickel actually goes straight down. And what I really like about this video is you can see, as I'm playing it back here, the nickel, after the cardstock is moved, is in the exact same spot. It's just moved up a tiny bit. And from there, when the cardstock is finally completely out of underneath it, it flies straight down to the bottom of the beaker. Alright, at this point in time you know that an object at rest tends to stay at rest, but the opposite is also true. An object in motion tends to stay in motion. In this setup we have a student over to our right who's running in the halls with a tennis ball, and what they're trying to do is, as they're running, they're trying to drop the tennis ball so that it lands in this hula hoop. So let's go ahead and watch what happens. Okay. When we watch that back in slow motion, we can see that the point at which the student drops the ball is actually about right here. You can see him loosening his grip on the tennis ball. And even though he's way back here, the tennis ball is still going to land inside of the hula hoop. And the reason why is because while the student was running, the tennis ball was moving too. Once the tennis ball is dropped, it will continue moving into the hula hoop. So that's the second half to Newton's first law of motion. Again, feel free to try any of these experiments at home. Thank you all for watching, and I hope now you understand Newton's first law of motion.